Okay, so rule 5 is non-zero, then zeros without a decimal are not significant. So this would be like 100. This is a non-zero, so that one counts. But because there's no decimal point mark, we know the decimal is really there, right? But in chemistry, this actually is different than this. This one doesn't say it has that decimal there. So these are not significant. So this 1 is a guess. So this only has 1 sig fig. And if you're like, well, that doesn't make any sense, totally understand. Think about this graduated cylinder. Here's 1,000 mark on it. There's no other marks, but the liquid goes to about here. What's your guess? If you line up the meniscus and you look right here, my guess is that it's 100. It's not a great graduated cylinder because I'm guessing, right? What are you guessing? You're guessing the 1. So that's our guess. That's the only sig fig that would have 1 significant figure. Now, if you look at this 100 with the point, okay, well, what kind of graduated cylinder is that? Well, it would be a more accurate one. It would be maybe there's an actual mark for 100. So there's the mark. The meniscus goes right to that line there. So to show that, we need to put the decimal there. So for this one, we would have 1, 2, and then 3. This would have 3 significant figures because it does that whole non-zero and then decimal point, and everything in between counts as well. So back to rule 5. There's no decimals shown here, so then the zeros on the right will not count. 1,200, that counts. That's our guess. So this has 2 sig figs. The 1, it's a non-zero, so that's significant, but the 0 here is not. So this only has 1 sig fig. The 1, the 0, the 4, and the 7, they are all significant. These are known. This is our guess. So it's 1, 2, 3, 4. 4 sig figs. And then here we have 0 to the left, which doesn't count. And then we have 1, 2, 3, 4, 5. This 0, there's no decimal, so that one doesn't count. 1, 2, 3, 4, 5 sig figs. So we know, and this is the guess. Now, even though these zeros are not significant, they are important for the scientific notation. So let's do the first one together, and then I'll let you try the other. So we have 1,200, and we want to put this in scientific notation. Now, even though we said, hey, there's no decimal being shown, that's the difference in chemistry, is this where it's shown is different than this one when it's not shown. We still know it's there, but again, the reason is this is when it's not there. It's a real big guess, and this is when it is there. There's an actual line that tells us, all right, this is 100. For this one, we know that the decimal is here for the scientific notation part. So 1, 2, 3. It's 1.2 times 10 so that we were going to the left, right? So that's positive 3. Notice I didn't put the zeros in here, and that's because they're not significant. Remember, however many sig figs you have, that's how many coefficients you need to have, how many digits you need for your coefficients. So you need 2. Pause the video, try the next 3, and then click play on the video. Okay, for 10, our decimal point is here, so we're going to move it over once. It's going to the left, so it's going to be positive, and this is going to be 1 times 10 to the first. Again, you cannot show the 0 because it's not significant, right? 1, so there can only be 1 digit there. For 10,470, our decimal is that 1's place, right? 1, 2, 3, 4. So we moved it over to the left 4 times. So it's going to be 1.047 times 10 to the 4th. And it's positive again because we're going to the left. And the last one, we have 0, 100,000, 940. So with this one, this 0 doesn't matter. You don't need it. This 0 is not significant, but we still need it for the decimal place. So 1, 2, 3, 4, 5. We went to the left 5 times. So it'll be times 10 to the positive 5th. And now we'll write it as 1.0094. 5 sig figs, 1, 2, 3, 4, 5.